So association rule learning actually is a technique which helps you arrive at patterns in your data. Okay, so suppose I have a data of this fashion where I have transaction data. So in transaction 1, these are the 4 items which were bought in a retail outlet. In transaction 2, these are the 3 items that were bought. Likewise, for each transaction we have some set of items bought, and so this data can be easily fetched from a retail outlet, whichever outlet sells all this stuff. Okay, now if I want to find that if I buy an item A, what is my possibility of buying an item B? So I will apply association analysis on this data, and I am going to get something like this. Yeah, I will get some rules. So one of the rules says a person who buys hard cheese is more likely to buy whole milk, and vice versa. A person who buys whole milk is more likely to buy hard cheese. A person who buys buttermilk is likely to buy other vegetables. So this will help me in placement of items within my retail outlet. That if I keep whole milk close to hard cheese, I will have a greater possibility of person who buys whole hard cheese is going to buy a whole milk as well. So that is going to give me a lift in sales. So this is what we call cross selling. Okay, so we can achieve this using association rule mining. And we also call this technique market basket analysis when we apply it on this transaction level data from a retail outlet. So is it clear, Aparna? And everyone else, if you have any question, please tell me. Okay, so we identify rules in databases using different measures of interestingness. Okay, the rule found in a sales data of a supermarket would indicate if a customer buys onions and potatoes together, he or she is likely to buy a hamburger meat as well. Such information can be used as the basis for decision for marketing activities. Example, promotional pricing or product placement. So product placement we already have discussed. Promotional pricing, yes, we can actually group these two items together and say that if you buy both these items together, you are going to get this much discount. So we already know that a lot of people who buy this item also buy another item. So there is an also interesting case study which is interesting research actually. What it was observed that in US, the most of the person who actually buy beer, okay, also buy diapers for their kids. So this rule actually came from this association rule mining only. So the reason behind this was that during weekends, most of the people would want to stay at home. So those who have kids bought diapers for their kids while they so that they actually don't have to go out on weekends, and they also bought beer because they wanted to enjoy the weekend. So this was very unusual relation, but it came out from association rule mining that sales of beer was related to sales of diapers. Okay, so Senthil has a question. He is asking difference between clustering and association. So Senthil, in clustering, I am grouping my observations. I am actually telling you technical difference right now, but application wise it can be used for the same set of problem, and it can be used for different set of problem. So in as clustering, we were grouping our observations based on their attributes. Okay, so that we were actually forming 4 groups, maybe n number of groups. So the characteristics of members within the groups was same, so we can give same treatment to everyone who falls in that group. But here we are actually finding patterns. We are not saying that observation 1 is related to observation 2 or observation 3 is related to observation 4. We are finding patterns that it in most of the cases we are observing this kind of pattern, like hard cheese and whole milk. So these are the one of the values these are values in one of the variable, and we are just finding patterns in values of those variable. We are actually not grouping our observations. But yes, if you come, you actually have a very valid question. But if you actually come to the concept of product recommendation, so yesterday we discussed that we can use clustering analysis for product recommendation, where we recommend same set of products to all the guys who fall under one cluster. That was one method of product recommendation. And if you come here, you again can use this association rule mining for product recommendation. You can recommend whole milk to a person who buys hard cheese. So application wise, yes, it is definitely same. And yes, one more technical difference, that clustering we were doing on data which was having numerical fields, numerical attributes. Here it is finding patterns on text. This is one of the technical difference. Though application can of both can be the same. Moreover, I have used association rule mining on clickstream data. Clickstream data is the weblog data. So basically, if you get information about your website, whether information something in the form like a person who means you have information that a person X is sitting on Google is sitting on some say Mac operating system, is using Google search engine, is using Mozilla browser, is visiting your site, and is visiting job page on your site. All this kind of what page he is visiting on your site. So all this information you have. Now you want to find pattern across all these attributes. So if we find pattern, we might end up getting something like this. A person who is sitting in US is more likely to visit the job page on my website. Yeah, so Balaji, as we go into details of this association rule mining, we will see that there are some statistics obtained within this algorithm itself, which actually which actually gives the figure that number of times this event has occurred. We call that statistics as support. Krishna, I am not sure about negation. Balaji, what example you need? Snippets example as in? So maybe you are talking about this weblog data. Okay, so what I will do on Monday, I am going to give you a case study, which actually I will give you to solve. So in that case study, I am going to give you weblog data. I will prepare a dummy weblog data, and I am going to give it to you as case study where you find patterns. So let's move ahead with solving this problem in R. So I am going to read this detailed data. So it's quite a big data. Okay, so So I'm going to read this file, and it actually has 43,368 rows. So actually my system is already overloaded right now. So it's going to take 2-3 minutes to read this file. Okay. So guys, one of the key things here with association rule mining is here that your data should be in transaction format. So like I have shown you data that in one column there should be transaction ID, and in another column there should be values corresponding to those transactions. Okay. So this is you can say it is a limitation, or it is a definitely we cannot violate this rule, because if we want to do association analysis, first we will have to pre-process our data in that format. Okay, so library for association rule mining is AR rules. So if you don't have that library, you need to install it on your system. So I will tell you how exactly you can install this library, because I think this is the first time we are actually downloading a library and using it. Otherwise, most of our task was done using base libraries available in R. So for association rule mining, we need a library called AR rules. So first I will go in packages. I will select CRAN mirror, and then I will select USACA1, because this is the mirror which actually hosts most of the libraries. Now once selection of mirror is done, I go in install packages, and I select this AR rules library because I want to use it. It's actually A rules, yeah. A rules. I select this library. I click OK. So now currently this library is being installed. So guys, please have a look at the URL. It is trying to download this library from cran.crn or .berkeley.education website. So this site is actually repository of most of your libraries. You can actually browse through this website and see what all libraries are available. Otherwise, you can always go in CRAN site. You simply type CRAN on Google and you will get repository of R's website. So CRAN is basically Comprehensive R Archive Network. So now this library is downloaded. Now if I want to use it, first I will have to invoke this library, because this library is downloaded but it's not yet invoked. To invoke a library, we issue a library command, and within the quotes we pass name of the library. When I run this, it's currently invoking the library. So you see the library is invoked, and if you see read it very carefully, this library is not invoked standalone. It uses matrix and lattice as other two libraries as well. So it's not necessary that a library in R in standalone is standalone. Sometimes it requires it is dependent on other libraries as well. So when I was actually downloading this A rules, it actually downloaded matrix or lattice package. But in my system, it was not doing this, because matrix and lattice package were already there in my system. But in your case, it might download matrix and lattice by itself, because there is dependencies across between these libraries. Okay, so I have invoked the library. Now I'm going to read the data. Okay. So this is the code to read the data. Read dot transactions, file equal to the name of the file which I want to read. Remove duplicates, true. Format equal to single, separator equal to comma, and I want to read column equal to first 1 and 2. I just want to read first and second columns. So Balaji, you are getting an error while downloading the library. Have you selected USACA1 mirror? So Balaji, let me take this issue with you after this class. One of the reason could be, I will tell you, one of the reason could be if you are sitting on your office system. I'm not sure whether you are using your personal laptop or office system. So in most of the offices, what happens that, okay, the firewall, you need to actually get firewall access through this site. In my office itself, in previous company, actually the firewall, these sites were restricted by firewall. So we will check this after this class. I'm going to take control of your system and we will check this. Okay, now guys, you see I am getting an error while reading the file. No such file or directory. So basically why this is why we have this error, because actually I have not set working directory to that path. Okay, so I actually need to go and change directory and I need to browse to that path. There is another way to set working directory, which I didn't tell you earlier. I should tell you now that I can use this function called set WD. Set WD means set working directory, and within the quotes I will pass name of the folder, means path and name of the folder. This is my folder where actually my data is sitting. Now guys, when I run this, again I get an error that /p is unrecognized escape in character. So actually just remember, if you are on Windows system, you cannot use / standalone. You need to put 2 slashes. One slash acts as an escape sequence for corresponding for the following slash. So I hope everyone is familiar with concept of escape sequence. Whenever we want to have a special character in our string or data or variable or anything, we actually precede it with an escape sequence to tell the system that the following character is not a special character, but it's actually the part of the string. So this is the way to set working directory if I don't want to do go through this browse, change directory and all that stuff. Now it's currently reading my transaction file groceries. So guys, do you have any confusion till now? Now I am going to use this a priori algorithm. So association rule mining is basically, okay, there are two algorithms for association rule mining. One is a priori algorithm and one is FP growth. FP growth is frequency pattern growth. So we basically use a priori algorithm in general. Okay, so I will tell you how exactly this a priori algorithm works, and this is the algorithm which is used in most of the case. RM duplicate equal to true. Balaji removes duplicates within the transaction. So suppose within transaction 10, a person buys white bread, again buys white bread. So if there are duplicate entries of white bread within a transaction, so RM duplicate is going to take care of that. RM means remove. So this is the function which calls association rule mining. We call this algorithm a priori algorithm. And if you see, I have passed three parameters: support, confidence, and target equal to rules. So I will tell you what exactly support and confidence is, and we actually want to arrive at rules. So we have given target equal to rules, and I am actually not familiar what other values we can give in target, because I have already used rules, since our objective is to find rules. Now when we run this, if you notice here, how many rules are there? Yes, we get 610 rules. Of the entire data, we get 610 rules. So it all depends, the number of rules you get, it depends on the value of support and confidence you pass. So don't worry, we are actually going to discuss what exactly support and confidence is. Now I want to see my rules. So since I have most of the rules have been output to this, most means all the rules have been output to this rules object. So I do this inspect rules. Inspect is the function. Within inspect function, I pass the object to which I have assigned association rule, output of association rule mining. Now when I run this, I get something of this sort. This is my output. Okay, so you can clearly see a person who buys hard cheese also buys whole milk. The person who buys whole milk also buys hard cheese. So this is a person who buys berries also buys other vegetables. So we can actually decide on placement of these items together in the shopping mall. Now these rules are based on a person who buys product A buys product B. But we can get these rules based on multiple cardinalities as well. Like this. A person who buys curd and yogurt will buy whole milk as well. Now it's like a person who buys product A and product B is likely to buy product C. So now you are working on multiple cardinalities. So association rule mining or a priori algorithm not only gives you rules based on single cardinalities, it's going to give you rules based on multiple cardinalities. Okay. Like a person who buys other vegetables and pork is likely to buy whole milk. Okay. So if you notice over here, we get three statistics: support, confidence, and lift. So these actually statistics actually help us decide what rules are most prominent. It's not necessary that every rule will have good possibilities. So we need to actually figure that out, what rules are actually having a good probability, or what rules are most prominent in my data. Okay, so I will tell you about how to go about interpretation of support, confidence, and lift. Okay, so support is Yeah. So support is something like this. Let me just scroll down and give you an example. So for hard cheese, we have, okay, for a transaction which contained hard cheese as well as whole milk. Okay, just a minute, just a minute. Okay, support of X. Yeah. So here we are going to talk about hard cheese only. So support tells that, you see the figure is 0.10. So in 10% of cases, in 10% of transactions, hard cheese is present. Okay. Here in 12% of transactions, onions are present. So support gives actually the proportion of transaction in dataset which contains the which contain the interest. So basically, in what is the proportion of having X in my data? So my rules are in the form of say if my rules are in the form of X leads to Y, as in hard cheese leads to whole milk. So support gives occurrence of X, the proportion of occurrence of X in your data. Is everyone clear about support? Or do you have any confusion regarding the support? Guys, you can ping here if you have a confusion, or if you don't have confusion. Yeah, it's then Sarvandan, it's not necessary that transaction are daily. Yes, you can say it's give you they can be simply transactions. So there can be multiple transactions within one day. So basically occurrence, okay, if we have 1,000 transactions and if I say support of onion is 10. So what I mean means 0.10 or 10%. What I mean here is in 10% of transactions out of 1,000, onion is definitely there. So in 100 transactions, an onion has been bought.